Hi friends, good morning everybody. Welcome to Rams Academy. We welcome everybody for this introductory first video of the Rams Academy. We are very happy today in bringing out the first video about multimeter. For information, the multimeter is very important one for electrical and electronic engineers, like for a medical doctor to diagnose the various diseases of a patient. How a stethoscope is being useful, the same way multimeter is going to be very much useful for electrical electronic engineers. For information, in electrical technology as well as electronics, everywhere there are a lot of parameters like voltages, currents, pulsating voltages and everything. There are going to be DC current, AC current, the continuity of a PCB, and then how the diodes are going to function, how the transistors are functioning, whether they are good in circuit or outside the circuit, and all these things can be found out to be okay or not using the multimeter only. Therefore, we thought to take up every aspect of electrical electronics technology. We thought first thing is we should educate the students and the other people about effective use of multimeter. Multi means so many. Multimeter means this multimeter consists of voltmeter, ammeter, and then resistance meter, and then how to check up the continuity, and then diode checkup, the transistor testing, and all these things are being carried out using the multimeter. That's what we are going to see practically now, and until then, thank you very much. Let us move on to that video. Thank you. Come to the video. This is the continuation of the multimeter explanation. Practically, I am going to show you how a multimeter is going to look like, and then what all the things can be done using that multimeter. For information, as I have already pointed out, multimeters are very much useful in checking up electrical and electronic circuits to find out whether a particular device is working or not, whether there is going to be a defective component, and all these things can be found out. That can be done in the circuit as well as outside the circuit. So here, for information, there are two types of multimeters available. They are called as analog multimeter and digital multimeter. In analog multimeter, just 15 years back and all, it was frequently available. It was useful for many mechanics and engineers. But nowadays, digital multimeters are available. The cost of the digital multimeter is very less only, but it is showing the accurate value and all. You don't look at the dial at all. Directly, you will be able to read the voltages, currents like that. That is the advantage of it. For information, I have used several digital multimeters. Here, the two multimeters are shown here. The costing may be starting from 150 volt, 50 rupees to 5,000 rupees. Multimeters are available. Therefore, this type of multimeter is available costing about only 200 rupees maximum. This is the meter. I am using it for the past 1 year. I purchased for 900 rupees, but I think this is a very good. I love this meter. This is very much useful. Several times, and even when we are doing some mistake, it is able to withstand all those things. So it is a rugged one. Therefore, I like this meter. Okay. So here in the multimeter, you know that. So you can keep it in any position like this, horizontally, vertically, anyway. The reading is not going to change. But of course, in analog multimeter, as there is going to be a needle and it is going to deflect in a dial, therefore we cannot keep. We have to keep vertically. Accordingly, the needle is being pivoted to that. Therefore, there is a particular position. It will be showing the correct value. But it is not the case with the digital multimeter. That is the advantage. First of all, this multimeter has got on and off switch, because this is working with the digital battery and other things, digital voltages, DC voltages. Therefore, this has a switch to make it switch on or not. So here the first thing is I want to show here is there is a selector switch. Selector switch, now it is pointing at off position. When it is off, the battery is not connected to the circuit, so that you will not be able to measure anything. But this contains, as I said, this contains voltmeter. This is a voltmeter left hand side, this is the right hand side voltmeter for alternating current, and then current meter, ammeter, and then you have got a ohm meter. Previously I said this meter is useful for resistance measurement, so you can either call it as a resistance meter or ohm meter. Ohm means is the unit, and resistance is the particular parameter. Therefore, this contains, there is a continuity checking selector position, and with that now you can find out whether a wire or any track in a PCB it's okay or not. All these things can be found out. And then this contains 3 sockets and the 2 test prods. One test prod is the red color, another test prod is the black color. And then first, normally you have to use only these 2 test holes only for these test prods, one for black, one for red. Black is the common. Common means in a particular circuit the voltage in every point may be with respect to a particular ground only. Therefore, negative can be connected to the ground and the positive can be moved on from point to point, and then we can measure the voltages. So therefore, a common point is there. Common point is the black, and common the voltage to be measured is measured using red only. Therefore, there is one more hole which is meant for a particular application. The application is nothing but measurement of the higher current of 10 ampere. This particular circuit is being used. In that condition, the red test prod will be moved to the circuit, and accordingly you have to select the particular position in the selector switch, and then you can measure the current of DC current of 10 ampere maximum. Okay. Coming to the voltmeter, this contains voltmeter of AC as well as DC. So first, AC voltage, the particular supply coming to our domestic supply is only 230 volts plus or minus 10% volt AC voltage. Therefore, to measure that voltage, this V, it is shown that the 2 selector points are there, the V and then sinusoidal this thing. That means these 2 can be used for measuring AC only. You should not measure DC here. Therefore, in a DC meter, you cannot measure AC. In AC meter, you cannot measure DC. But there is one advantage is there. DC voltage. In DC meter, you should not measure AC. But in AC meter, you can measure DC. Nothing wrong, but it will be showing a little higher value or lower value. Because DC is nothing but an alternating current only, but with 0 frequency. That's the meaning. Therefore, DC can be measured in AC, but AC cannot be measured in DC terminal. That engineers are supposed to know. These are tips. One of the tips I wanted to share with my technicians. Okay, here there are 2 ranges, and then I am moving to 200 volt, and the AC voltage of 200 to 600 you can measure. Maximum 600 volts you can measure. The incoming voltage for a domestic power supply in India is 230. I kept in 200. Now I want to measure the DC voltage. The voltage comes as more than 200. Therefore, it is showing 1. More than 200 means it show 1. Then I can move on to 600. Now it is showing 239 volt. So like that, for any value, suppose a reading goes beyond 1, that means you are supposed to move to the higher range to find out the accurate value. This is meant for AC voltage. And then suppose if you want to measure, the AC voltage, and then if you think the voltage is going on shifting, and then you can put the hold on switch, and then by that way you can stop, you can arrest that. The reading will be stopped over there. And then if the reading is not very much with the sufficient light, and then there is a switch that will be able to show you the correct value by switching on this. This is a switch for that purpose. And then this I have discussed for voltmeter of alternating current. And then let me move on to the voltmeter, that is the DC voltmeter. DC voltmeter has got the range from 200 millivolt to 600 volt DC. Here it is shown as V straight one line. Straight one line means it is showing that this is a voltmeter for DC. And then there is going to be a dotted line. The dotted line shows that we can measure not only the filtered DC, exact DC, but you can measure the pulsating DC. For information, this is a tips for the technicians. A perfect DC is available from battery only. But anything, whatever you take it from a DC power supply, everywhere, the DC cannot be equivalent to a battery. Battery can give you a pure DC, but rectifiers and filters, all these things can give a DC, but with the little ripples. Okay, so here the voltmeter can measure a minimum voltage of 2 volts to 600 volts DC. And then coming to the current, there are two types of currents, that is ammeter to measure the AC current, ammeter to measure the DC current. Here this particular meter is meant for measuring DC current only. There are certain meters, they are available, they are called as tongue testers. The tongue testers can be used for measuring the alternating current. But here it is, we are not maximum, we are not going to measure AC current and all. Therefore, you can understand that there is another current meter for measuring AC, and that is the tongue tester. Here to measure the DC current, the minimum most current is going to be 200 microampere DC current, and then you can move on to 200 milliampere. 200 milliampere you can measure. If you think that you have to measure the current, DC current beyond 200 milliampere, as I said, there is going to be one position, the selector can be kept over there, and that can be measured up to 10 ampere by shifting this red plug to the another socket here. By that way you can measure. So this is about DC current measurement. Here A and straight line is put. Straight line means it is called DC ammeter, and then there is going to be a dotted line. That is, it can measure not only the perfect DC current, it can measure the pulsating DC current also. And then coming to one more important parameter in electrical technology as well as electronics, there is a resistance measurement. Resistor is used for resisting the flow of current in every circuit. There are a lot of resistors are available, carbon resistor, wire wound resistor, like that. So many resistors are there, variable resistor, fixed resistor, like that. So many resistors for a particular current rating, all these things are available. Therefore, all these things can be checked up by using this particular reading starting from 200 ohms to 2 meg ohm. The minimum most resistance is ohms, and then highest resistance is meg ohm. A resistor can have this value. Normally, the insulator has got infinite resistance. A resistor has got a particular value. And then in between value you can measure. Therefore, whatever value you think you want to measure, between the reading of 200 ohms to 2 meg ohm you can measure. For information, there is one more tip I want to tell my students, that our body is also a conductor that is also having a particular resistance. That is why when we touch electrical voltage, it passes the current through our body. We are able to sense the shock of that, because of the current flow through our body. Normally our body resistance is about 1 meg ohm. Therefore in tester also there is going to be 1 meg ohm in series with the neon lamp, and when we touch it, the current will flow through our body, and because of the resistance, current is going to be minimum. But because of the voltage drop across the neon lamp will glow, and that shows that a particular terminal has got AC voltage. That is the way the tester used to work. Now coming to this point, and then coming to this continuity testing in several circuits, in electrical component, electronic components, there are wires, there are electric copper tracks and everything. These tracks, because of the current flowing through that, in due course the copper track may become cut, it may become opened. Therefore continuity may not be available, so current may not flow. If the current is not flowing, the circuit may not perform properly. Therefore, to find out all those things, we are using this continuity testing by keeping the selector switch in this, and this is going to give you a howling noise or a buzzer noise like this. So once it shows that the wire is good or the track is good, by that way we can confirm that the particular circuit is working properly. And then coming to the next one, measurement and checking of your diode. The diode we know very well is semiconductor diode. Diode has got a single junction with the two terminals. It will be showing a high resistance when it is reverse biased. The diode will show very low resistance in the forward bias. All these things can be checked up by keeping red to the anode and black to the cathode, or black to the anode and red to the cathode. By that way, whether in reverse mode it is showing high value, or forward biasing shows low value. By that way, we are able to confirm that diode is functioning or not. And then coming to one more device, important device in electronics, beyond this diodes, there is a device called transistor. Transistor with 3 terminals. The transistor contains base, emitter, collector. The transistors may be either NPN or PNP, may be of silicon transistor or a germanium transistor. These 2 transistors can be checked up by having this socket. This circuit shows that there are 4 terminals in the horizontal line above, and the bottom one PNP, 4 horizontal points are there. Therefore, the transistor's terminals are inserted according to the base, emitter, collector for an NPN at the top and PNP at the bottom. By putting it, we are able to measure the HFE values, the beta gain. And if it shows a particular value not showing 0 or not showing 1, then in that condition the transistor is very good. By that way, we are able to compare. For information, I want to give a tip for the students, and if they want to check up a particular doubting transistor, that can be inserted here and find out the value, and then they may be having a working transistor that can be inserted and find out a value. If both the values are same, and they can confirm that the defective, what they think defective, they can confirm that it definitely defective or it is going to be a good one. Like that, they will be able to compare. These are the important things which are very much useful for information in electronic or electrical engineer. Now, without a multimeter, without an electronic device, we will not be able to diagnose the defects in electronic circuits. For information, the circuits are not simple circuits nowadays available. There are a lot of complicated circuits in computers and other things. Lot of circuits are going to be there. They are going to be connected one over another, like that they are merged. So for a particular application, when that is the case, to find out the defective component and other things, the multimeters are very much useful. We have to be engineer. As an engineer, we have to be very much thankful to the multimeter. Thank you very much. With this information, I think the viewers will be able to understand a lot of things. If they have any doubt, they can put it in the comment. In the next video, I will be able to answer all those things. Thank you very much for the patient hearing. Thank you.